I'm going to hand over to Patrick and Matt just now, and I'm going to let them go through their presentation. If they want to expand on their own history, then please do. But again, please feel free to ask questions. The presentation will run for about 45 minutes, and then we'll have a good Q&A session at the end of it, and we'll wrap up, and I'll find the key learning for myself out of the webinar, and we'll make sure that we hand over the details that need be. So I'm going to hand over to Matt and Patrick. Thank you very much.
Well, thank you, Bob. Yeah, good afternoon or good morning to everyone. It's a morning here in the US, early morning for me, but I'm happy to get in contact with all of you to kind of take you through precision and protection and why accuracy matters when it comes to flow testing. We're going to talk everything around NFPA 25. I appreciate the introduction. Like Bob said, my background is I've been in the fire protection industry for about 30 years. I was a firefighter and paramedic out in the Chicagoland area, and I also has started out as a fire sprinkler contractor many years ago. So I've been working in the industry for quite a long time, and I've been testing a lot of fire pumps and doing a lot of flow testing all throughout the U.S. now. In my time here with Hose Monster to help build our innovation with our Smart Monster line, which we're going to go over later today. And then this is my colleague, Matt Dawson. Matt, if you want to introduce yourself.
Thanks, Patrick. Morning, afternoon, everybody, wherever you're at. So I'm Matt Dawson, suppression sales manager at Noventis covering EMEA. So I've got 18 years experience in the fire protection industry. I joined in 2008. I joined as an apprentice, so really interesting journey through installation, maintenance, being a technician. I then moved up to company management, which was great experience, and it's really great to see the issues and challenges we get for making sure that we comply with regulations and standards, and all the challenges that brings. Following that, I've had some management and commercial roles at some large global companies, and I joined Noventis Safety in January of this year. So it's been great joining such an innovation-led company, as you'll see today with Hose Monster.
Oh, great. So as we get started here today, I just want to point out what we talk about is our legal parameters, right? I'm here as Hose Monster, even though I'm a member of and a committee member of NFPA. We are coming here just from our Hose Monster perspective. However, everything that we say here is really just our opinion of our understanding of the code as it is today. Now that's going to vary per country, and obviously we need to follow the rules of the land that you're in. But we're going to be coming to you today to talk more from a NFPA 25 perspective. So as we look at, so it's ultimately though the AHJ is going to have the final say and authority of how they want a test done. So we're going to be focusing a lot that we come to from NFPA 25, which covers is the standard for inspection, testing, and maintenance of all water-based fire protection systems. So that's going to include anything for maintained fire sprinkler systems, fire pumps, standpipe landing valve systems, and then as well as NFPA 20, which is the installation of stationary fire pumps. On the UAE follows the Fire and Life Safety Code and practice by the Civil Defense. And in that code book as well, too, they do reference back to NFPA and NFPA 25 and 20 as well when it comes to fire pump testing. And then also the British standards of BSEN 12845. Wherever you're at in the world, always consult with your AHJ and make sure you're familiar with the proper codes for your region.
So I'll just introduce you to Noventis Safety. We do have a few brands in our portfolio, but it's just worth knowing a little bit more about the company that we represent. So Noventis Safety is a technology-led safety solutions and testing equipment manufacturer. We do have two separate pillars. So we've got the fire pillar and the suppression pillar. Under the fire pillar, we've got detector testers and SDI. So it's probably brands that I would guess that you're aware of because they do have a very large global presence. They the technician in the picture is using the new XDR2 tester that we have out, which is something I certainly wish I had when I was an engineer. We're basically looking to lead with technology to increase compliance to local standards. So anything to test detectors, we've got remote options, and as you can see there, handheld options. In the suppression pillar, we have 3 brands. We've got Hose Monster, which we're going to talk about today. We've got GVI, which we'll also cover, and then we also have TSI. So we're not going to speak too much about TSI today, but just to make you aware, TSI make portable flow meters, and they use separate technology to what we're going to discuss today. They use electromagnetic technology for their flow meters. We do also have at TSI separate applications. So we've got 2 that I'd just like to mention briefly. One of those is fire appliances. So we basically install our electromagnetic flow sensors on fire appliances, fire trucks, to give the firefighters and the control staff all the information about the water levels they've got, flow rates and things like that. And it basically allows them to make informed decisions, which is really important because they're dealing with an active incident and potentially people's lives. So it's really important. The last section for TSI is something we call PFT meters. So we deal with water utility companies in the UK and further afield, and we're basically looking at water discoloration. So PFT stands for pressure, flow, and turbidity. Turbidity is what we're looking at specifically for this application, and turbidity is the measurement of water discoloration. So basically, if you get dirty water coming out of your taps, we're looking to take a proactive approach to measuring that and managing it. We've got software, hardware solutions. I'm not going to go into them today. We're not. But if there is any interest, obviously reach out, ask any questions. We do have a website which has got some great information, which is tsi.ie. But that's an overview of Neventis.
Great, thanks, Matt. So yeah, so to get started, why are we here today, right? Why accuracy matters. And we're going to come to you we're going to show you the data, what the data shows. So in the United States, we try to track every fire sprinkler activation throughout the country. This is done through the local fire departments. As the fire department goes out on a call, no, it doesn't matter if they're going to a car accident, a nuisance fire alarm, or an actual fire or fire sprinkler activation, they're going to document that in a report. Those reports are then sent up to the local and state levels, and then to the federal government level where they compile all the data together. So NFPA takes all that data and they study it, and they track fire sprinkler activations. And what we've found really at least over the past 25, 30 years, we consistently have about an 11% failure rate. That means that when a fire happens, the building has a fire sprinkler system, and the system fails to operate or effectively operate properly. Now, majority of those failures, as we can see down here in this pie graph, that 8%, so the vast majority of failures is because someone shut a valve. A valve was shut that shouldn't have been shut. Now, what does that likely mean? That means that a system was most likely taken out of service. It was needed for repair, and then it fell through the cracks from there. Either the building owner didn't follow through with the estimate, the AHJ, the insurance company, failed to notice that the system was out of service and failed to get it in touch. However, the other failure, that 3% failure, is this little bit deeper dive here on the right. And ultimately, this is going to come down to really a lack of water supply, a lack of proper water supply. So 78% of that failure rate comes down to just not having enough water to discharge to the seat of the fire. And if we think about why we do what we do, why NFPA even was started, is it's a study of tragedy. People have lost their lives. Over the past 130 years that fire sprinklers have been around, we have still seen tragedy unfolds throughout the United States and throughout the rest of the world. Going back to the Iroquois fire in Chicago, where 562 people were killed and lost their lives in a theater fire. 2017, the Grenfell Towers back in the UK. Or even just more recently in the news over the past 6 months or so, we had a terrible tragedy in Hong Kong last November. We had in Switzerland on January 1st of this year, a New Year's Eve fire in a bar, as well as in Thailand just a few weeks ago. We had another horrible tragedy. So fire burns just as hot anywhere in the world. It doesn't matter what country you live in, what area you live in. It's just as devastating. Uh, and it's something that we can now help try to fight properly. But when we look at the fire deaths in the US, so this chart here starts in 1980. So we're going back about 45, almost 50 years ago. And we can see our death toll was up to nearly 7,000 people a year in the US. But then we saw, and that's really the boom of fire sprinkler systems in the United States in the 1970s and 80s, when we had a large construction boom throughout the US. That's when a lot of fire sprinkler systems were activated and installed properly. And as you can see, fire deaths rapidly started to drop over the next 20 years. There's a blip there in the center there for September 11th, as those fatalities were contributed to fire deaths. But then the fire rate can still continue to drop until about 10 years ago. And we look a little bit closer over these past since 2014. Fire deaths have now started to increase throughout the U.S. We're up a 27% increase over the past almost 13 years now. So we're moving in the wrong direction, right? And so we need to make sure that the jobs that we're hired to do when we go out there and we inspect these fire sprinkler systems and we install them properly, that we're doing so with the intention to know that we need the system to work, whether it's 6 months from now, a year from now, or 10 years from now. The work that we do today matters, and it's going to make a difference down the line. And it is going to be one of these unthankful positions where you'll never know the lives that you save based off of the work that you do today. But that's where here at Hose Monster, we're here to help. So everything that we do here at Hose Monster is all around the basis of water supply. So that's why testing fire pumps do an annual flow testing. Whether you're flowing water externally with a Hose Monster device to challenge that fire pump, or using a flow meter like our GVI flow meters to measure the output of that fire pump. Performance hydrant testing, making sure that the fire hydrants are adequate and up to the task for the fire department to hook up to in the need of that fire. And as well as the hose valves inside the building, the firefighter hose valves. Here in the United States, we call these standpipe connections. But I know depending on where you're at in the world, we have a lot of different names for these firefighter hose valves that we're going to find, in the stairwells of high-rise buildings. So landing valves, internal hydrants, dry risers. There's a term for just about anywhere you go throughout the Middle East and Europe. And so it really all starts with our Hose Monster technologies, our pedalless nozzle technology. So Hose Monster here, we measure water flow very accurately and a little bit different than a lot of other components out there in the world. A lot of people are familiar with the pitot tube, the handheld pitot tube that really started it all. However, that pitot tube is difficult to use because the accuracy is questionable depending on how it's being applied properly in the technician. A pitot tube has to be put into the water stream at a very particular location to get an accurate measurement. We saw how inaccurate that was when we started our company here back in the about 30 years ago. And Fred Grenning, the founder of Hose Monster, determined that there's a different way to measure water flow. And that's where he came up with our pedalless nozzle technology, where we take an internal nozzle pressure reading off the side of the road and off the side of the nozzle. And as that nozzle narrows down, creating a nice laminar solid flow. So we get a very accurate reading. And not only do we get an accurate reading, but there's no equipment to break, get clogged, get damaged during the test as all the debris passes through the water flow. And then now we're just taking a pressure at the side port of the nozzle. Now, all of our equipment is FM approved. Here in the United States, FM holds us to a very high standard. We have to be greater than 2% accurate. So all along our pedalless nozzle sizes and all Hose Monster devices, we have FM approved. We have 4 different sizes for our pedalless nozzles. So depending on the application and the test that you're doing and how much water you're expecting to flow, you would apply the proper pedalless nozzle to the proper size. Our 2-inch pedalless nozzle, which has a 2-inch discharge. Now, all these nozzles here that I'm showing on the screen, this is just a small selection of our product catalog. But this is a 2.5-inch connection or 65 millimeter connection on the inlet side. We can also get these adapted to the proper connection for your region. So whether you're using a British instantaneous coupling or a national hose thread or a national standard thread, we can get you the proper adapter to connect to any of your water flow devices. But as you can see, each different nozzle size has a different range of our accurate measurements. So our 2-inch pedalless nozzle is going to be great for large flows when you're hooking up to a hydrant and you want to maximize your flow. So our flow range is going to be anywhere from 500 gallons a minute to upwards to 1,400 gallons a minute. And then stepping down to our 1 3/4, which is a very good sweet spot for a lot of fire pump testing, as well as probably for some most hydrants around the world, at 250 gallons a minute to 981 gallons a minute, which again is going to be approximately 1,000 liters per minute up to 3,800 liters per minute.
So Patrick mentioned GVI, but GVI is our static flow meter range. So whereas Hose Monster's portable, GVI is static, and we install these on test loops. So the difference would be if we were testing a fire pump using Hose Monster, we would flow water out of the test header externally and discharge that water. With GVI, we're using an internal test loop and we're not discharging that water. It's staying within the system. Some really important points with our GVI flow meters. We're 0.5% accurate, and we're really, really proud of that. There's some manufacturing processes, some design processes that all contribute to our accuracy. So we are really proud to say we're the most accurate Venturi fire flow meter on the market. We use CNC and Swift lathes, thick-walled US steel, basically looking for superior quality, 5-year warranties. On this meter here, you can see the red hose is the high pressure, and the green hose is the low pressure. And we're basically using the Venturi principle to measure flow. With our GVI gauges, we've got some different options. So on the one we just saw, that was our standard gauge. We are seeing a lot more people tend to go for the glycerin filled. So when we talk about the accuracy, what we're doing here is we're testing fire pumps, and there's a potential that if we get a wrong reading, we might fail a fire pump. So we need to make sure that the readings we're getting are 1 are accurate and 2 are read correctly. So the first solution we have for that is our glycerin filled dial. Glycerin's basically a clear syrup. And what we're looking to do with the glycerin is take away the needle bounce. So we're looking for a cost-effective, accurate gauge that can be read really easily. Again, we're really proud to say that this is the only FM-approved glycerin-filled dial on the market, and that's why we're seeing a big uptake of it. We do have other options. So in the middle, we've got our hybrid dial, which is glycerin-filled again. What we have with that is a 4 to 20 milliamp transmitter, which is a hardwired connection, which would go to third-party equipment, fire pump controller, that kind of thing, which gives you the best of both worlds. And then on the right hand side, we've got a full digital option. So it's obviously it's easy to interpret, as well as that hardwired transmittable option. So yeah, we've got the full suite of options, all FM approved. So just a note, when we're installing, just a few installation considerations to take into account. We do need to make sure that we've got 5 times pipe length compared to diameter on the intake. So in the instance on the image, we've got a 6-inch pipe. So it's a 6-inch installation. That would mean we would need 30 inches of pipe beforehand. And basically what we're looking there is to get a stable and fully developed flow profile to make sure that the water goes through without turbulence, eliminates excessive swirl and things like that. On the discharge, similar principles apply, but this time we just need a 2x. So again, still a 6-inch installation, obviously, and that means that we need a 12-inch length of pipe for the discharge. And again, we're just looking to eliminate excessive swirl, turbulence, and we're looking for stable, repeatable performance. We've got the best equipment. We just need to make sure it's installed correctly, obviously, so it works. We need to make sure it's clear of obstructions, valves and bends, because they all contribute to turbulence.
Now, I can't speak for all flow meters on the market, but I can tell you if it's a Venturi flow meter, which is a 300-year-old technology. Giovanni Venturi, the Italian physicist who studied water flow, is the one who came up with the principle of measuring high pressure versus low pressure, the differential pressure between the two as that water flows through that neck of the body, is what leads to an accurate measurement. However, all Venturi flow meters, whether it's a GVI flow meter or one of our competitors, um, please check with your manufacturer's settings for the proper installation of that device. I see a lot of flow meters that are installed improperly. They don't have the proper intake pipe. And when it comes to that, again, that's going to lead to an inaccurate flow test. An inaccurate flow test not only could lead to a systematic failure of your fire sprinkler system, it could also lead to unnecessarily repairs. If we fail that fire pump inadvertently just because the flow meter wasn't installed properly, that could go into a very expensive repair of that fire pump that may not need to be repaired or replaced at that time. So making sure that we have that flow meter installed properly is a huge, great first step to making sure that you're doing an accurate fire pump flow test.
So gauge calibration, again, this is something that we see not always followed. So we talk about the accuracy we need to comply with. As per code, we need to have gauges calibrated every year, so annually. There's a couple of tolerances to be aware of. So for fire pump suction and discharge gauges, we need to be within 1% accuracy, and any flow meters need to be within 3% accuracy. It is worth noting that if you use any other gauges that we don't supply, other gauges, all gauges have a tolerance. So you might be replacing gauges. Just make sure that the tolerance is the accuracy that is required. So again, 1% for the suction and discharge, and 3% for the flow meter. We obviously have calibration services. You can use any calibration house as long as they're certified. Again, as Patrick said, speak to other manufacturers if you need to, but the main thing is that that gauges are calibrated annually.
Great, thanks, Matt. So what we're going to do is I'm going to go over an overview of a standard fire pump test, a standard annual fire pump test using a flow meter. And to do that, we have to start with the basis of that fire pump. How is that fire pump designed? Each fire pump should have a placard, an informational placard attached to that fire pump. And it's going to show you some key information about that fire pump and and how it should perform when flowing water, depending on its flow rate. So it's really the benchmark of we're going to take that data, and that's what we're going to be comparing our test data, our observed test data that we're there to do that day, to this placard to make sure that fire pump is working effectively. So there's really 5 key components on that placard that we need to pay attention to. The first is the rated capacity of that fire pump, whether it's rated in gallons per minute or liters per minute. We want to look to see how much water is that fire pump designed to flow at its 100% flow rate. Here in this example on this placard, this is a 1,500 gallon a minute fire pump. While flowing, excuse me. And then there's going to be 3 net pressures on this fire pump, on this placard as well, too, that we need to worry about. It's going to be our rated max net pressure developed. That's going to be our churn pressure when the fire pump is not flowing any water. And then we also have our 2 net pressure readings while that fire pump is flowing 100% of its capacity and 150% of its capacity. So again, this 1,500 gallon minute fire pump will have a net pressure, which we'll talk about here in the next few slides. Net pressure is the pressure developed by that fire pump. That's the discharge pressure minus the suction pressure equals your net pressure. So while flowing 1,500 gallons a minute, we should see a differential net pressure of 110 PSI on this fire pump. However, then when we're flowing 150% of the fire pump's rating, so when this fire pump is flowing 2,250 gallons a minute, we should see a net pressure that's going to drop off, right? We're going to see we need to see a net pressure of 88 PSI. And then as well as our churn pressure when we first turn that fire pump on, that's going to be our max net pressure developed here. So on this placard here, that means that we don't want to see a net pressure higher than 125 while that fire pump is churning. And then another key component that we're going to need to make sure we document on every placard is how fast is it rated for, the rated speed. Here, this is listed as RPM at 1,780 1780 revolutions per minute. Again, no matter how we're looking at these, if this is in liters per minute or in bar versus PSI, knowing these details is crucial to making sure that we're doing a proper annual fire pump flow test. So as we look at our fire pump room here, there's a few things that we're going to be documenting when you do our flow test. What we're going to do is we're going to want to record our fire pump net pressures. Again, that's going to be your static or your suction pressure versus your discharge pressure. Discharge minus suction creates your net pressure. We're going to want to record our speed, and we're going to record our motor performance. Our motor performance is going to vary depending on whether it's an electrical engine that's feeding that fire pump or a diesel motor that's feeding that fire pump. And we need to be able to document those results at each flow point. So this would be just a quick template of the documentation that we need to verify for every fire pump test. So when we first turn that fire pump on, we're going to we call that our churn test. When that fire pump is just turning water, we're just churning water. We're not actually flowing water. So at churn, we want to document our discharge pressure, our suction pressure. We're going to calculate that. Discharge minus suction will equal our net. We need to determine our flow rate. So here for the churn, that's going to be 0 gallons per minute. And then we need to find out how fast is that fire pump moving. And then we need to document our amps and volts, which we'll talk about here in a few slides. And now a standard test per NFPA, a standard annual flow test is going to be our churn, 100% and 150% of our rated capacity of that fire pump. However, I do know that there's a lot of companies out there that also like to do a 50% flow test. So for the placard example that we saw there, that 1,500 gallon minute pump, we would set our flow rate to 750 gallons a minute and take our readings there. All this is going to go into what we call the curve of the fire pump, all this data that we're collecting. So first, we're going to be talking about how to set our flow rate properly using a flow meter. All those flow meters installed should have 2 control valves before and after that flow meter. Again, we remember the intake side. So depending on, this could vary per fire pump, right? Depending on how that water flow is flowing and which direction it's flowing. We want to make sure we understand the layout of that fire pump. Where's our discharge side of the fire pump? Where's our suction side? Because it's going to be very important to making sure that we're looking at that flow meter correctly. So we want to make sure that, again, this gauge has been calibrated. We know it's going to be accurate because we just had it calibrated for every year. We need to get this calibrated prior to our test. But the way that we're going to set this flow meter up is that we're going to open up this intake valve 100%. It's going to be fully open, allowing water to fill the entire pipe diameter here. This valve is currently closed. As this valve is open, we're going to fill this entire unit with water. We're going to bleed out. There's a bleeder valve on each side of the flow meter that's going to allow any air or any debris that gets caught in those tubes. We're going to make sure that gets flushed out properly so the meter has nice equal pressure on both sides going into the meter. And then when we're ready to start flowing, we're now going to use our discharge valve to throttle into our flow rate, right? So we're going to be just slowly cracking that valve open. And as we crack that valve open, we're going to watch that needle slowly move up the dial to get into the exact flow rate that we need to be at. Once we set our flow rate for our test there, so whether we're flowing to 100% of flow or 150% of flow, we want to dial this meter in. Once we have that flow set, that's when we're going to go and start taking our readings. So we're going to look at our gauges on each side of the fire pump. We're going to look at our discharge side of the fire pump, and we're going to document and record that pressure. And then we're also going to record our suction pressure of the fire pump. And then we're going to do a little math. We can do it after the test. We don't have to do it in the middle of the test. But we're going to subtract those numbers from each other. So discharge minus suction, and that's going to equal our net pressure. That's the pressure that fire pump is adding to the water that's coming into it. And after we record our fire pump pressures, we now need to document how fast is that fire pump spinning, right? We're going to be measuring the speed. And we do this by putting a piece of reflective tape on the shaft between the motor and the fire pump itself. So here we can see it's going to be right next to on this pump. It was right next to the packing gland, and we're going to use a non-contact tachometer, a laser tachometer, to count how many revolutions a minute as that fire pump is spinning. So what it's doing is that laser is bouncing off that reflective tape, and so as the shaft is spinning, the meter there counts how many times per minute that fire pump is spinning. And then the last piece of data that we need to record is going to be our motor performance. So if this is a electrical fire pump, we need to record the voltage and amperage at each phase, right, throughout the test at each flow point. Or if it's a diesel engine, we want to record the oil pressure and the coolant temperature. So there is no amps and volts to record with diesels. But we want to make sure that the oil pressure is stable and our coolant temperature is within normal conditions. The temperature range may vary per manufacturer of that diesel engine, but typically we're looking at around 180 degrees Fahrenheit. And I apologize, I don't know what that is in Celsius, but I'm sure we could do some math there to figure that out. But again, you want to consult your manufacturer's recommendations on the proper temperature rating for that fire pump. And so one of the other products we haven't talked about yet is our Smart Monster digital gauges. Using our digital gauges are going to help increase the accuracy of your fire pump test. So when we're recording our suction and discharge pressures of that fire pump, by using our Smart Monster digital gauge, we're going to get a far more accurate reading than our human mind, our human brains and eyes looking at that gauge. And that's where a lot of a human error comes in, is when it comes to properly reading that gauge. So our smart monitors can be used and replace any analog gauge on your flow test. So whether that's on your fire pump suction and discharge, or if you're flowing water externally through a hose monster device, or for any of your other tests as well too, for fire hydrant testing, landing valve, standpipe connections. Our smart monster gauges attached to any hose monster equipment. It doesn't matter if it's a 30-year-old legacy steel hose monster or a brand new pedalless nozzle. It can be adapted to any of our products. The way that works, it's a wireless charging battery that sends out, that powers our device, and it sends out a Bluetooth signal, Bluetooth up into 300 feet of range. So we get quite a far distance there. It's a full compound gauge, some negative 15 to 300 PSI. So again, this is why we can use it on either side of the fire pump at the same time. It works with our long range connect system, which is going to allow us to extend our Bluetooth range to any distance in the world. We can transmit that data to anywhere around the world using long range connect, which we'll talk about here in a few slides. It's a very durable gauge. It's IPX8 rated, so completely waterproof. We submerge these in a meter of water for a series of hours, and we take it out here and make sure it's still completely dry. So it's designed to hold up to the test and the rigorous demand of what our fire sprinkler contractors are going to see in the field. And we also have we drop test these up to 10 feet. I know I've dropped a few of these myself, right? When you're working in that fire pump room, that hard concrete floor, and you got tools in your hand, sometimes they will drop on you. These really hold up to the challenge. It won't get damaged as it's a very rugged design. And then we also have an LED ring on each gauge as well too that will show you the status of that gauge as well too, show your connectivity as well as if there's any issues with battery power or consumption. So the way that device works, right? It's going to Bluetooth signal to your mobile device. It works with all iOS and Android phones. It's going to pick up that Bluetooth signal, and now your phone becomes the face of that gauge. And not only does it become the face of the gauge to show you those pressures, but it could also be adapted to our hose monster products to show you the actual flow rate that's flowing through our hose monster products. If you have multiple lines flowing, we can show the total sum of the water flow. And it's also going to do a live net pressure calculation of that fire pump. So here we don't have to do any math in the middle of our test, right? We're going to have our discharge pressure minus our suction pressure, and that's going to show live up in the corner as we're doing our fire pump test. We can take screenshots. There's a screenshot button up in the top right corner. That's going to save your entire screen. So if you have multiple hose monster devices and not all of them fit on the screen, when you take that screenshot, it's going to take a picture of any of those devices that's even lower down on the screen, so you don't have to scroll up and down to take multiple photos. We can record each session as well too. We can bring that data directly into an Excel spreadsheet to document our flow tests. And that recording is also going to work as a water consumption meter. So we can document how much water are we using total during our test, especially if we're doing a hydrant test, we can now know how much water we flew total during that test. And then the great thing about it as well too is it's a universal gauge. So we can go into our settings and we can, if we want to display bar pressure versus PSI, or if we want to display liters per minute or liters per second versus gallons, we can set all that up in our settings. So it's very adaptable to any region of the world, depending on how you like to take your units of measurement. And like we were saying, this works with our Long Range Connect. Long Range Connect allows our Bluetooth devices, our smartphone devices, to pick up that Bluetooth signal from our first Smart Monster here. And then we're going to be able to transmit that data through our Smart Monster servers. And now anyone else who's logged into our company account, it doesn't matter if they're at the hydrant down the block or if they're in the office on the other side of the world. We can stream this data anywhere in the world. It's a very low amount of data. We've narrowed this down to be less data than a text message. And so as long as you just have not even a decent cellular connection, as long as you have a cellular connection, we'll be able to transmit that data to anywhere in the world. And then we have our Fireflow testing software. This works with or without Smart Monsters. This is a standalone product, but when powered by Smart Monsters, it's going to improve the accuracy of our tests. Our Fireflow testing software is it's a desktop and mobile access, so we can access that through our Smart Monster app, or we can log in through any desktop. But here's where we're going to be able to track and document all of our flow tests. So whether we're doing a fire pump test or a fire hydrant test, all this data can be put into our software, compiled into a very accurate NFPA style report. And then the great thing about it is that when you go back to these job sites year after year, you can see the previous year's data and compare and benchmark. So as I was showing earlier, right, with our fire pump room here, so now that we have Smart Monsters set up on the suction and discharge side of our fire pump, we're going to be able to get those data directly into that mobile app to see exactly what's going on with that fire pump as it's throughout our test there. So once we set our flow rate, we're going to be able to screenshot that and document our data. Or the great thing about that is that we're going to be able to bring the data directly into our directly into the software. So here's just a quick video. This is going to be showing a fire pump flow test. We're going to be flowing our water externally, as we do here a lot in the United States. We flow water outside rather than through a flow meter. So here it's going to our pedaless nozzles flowing through our little hose monster devices. And as you can see on the app, we're getting live data again transmitted directly back into our mobile device to see the data of exactly what's flowing and how the fire pump is responding at the same time. Or here in a typical fire hydrant test as well too. This is a 2-hydrant test. We have 1 hydrant remotely set up, transmitting that data directly into the mobile software. So as we do our flow test, you can see that we have our data that's streaming live directly into the app from our Smart Monster devices. Our reports are going to go through a very detailed report about that fire pump, all the data that we can enter in about that fire pump, our placard information, all this, every component that's in that fire pump room. It's going to take us through an NFPA style checklist, yes, no, NA. We can document any notes. We can take photos of any deficiencies as well too. And those deficiencies will be noted on a deficiency report page here. But then the photos will also show up on our photo page where we can match the deficiencies to the photos as well too, so we can see how that test went. And then not only that, but we're going to take all that data and we're going to graph all this data out. This is the more important part, right? We're going to be able to visually see what our observed data was compared to that fire pump's placard, making sure that the fire pump is up to the task and it's able to produce enough water to fight a fire that it was designed to do. Or if it's our fire hydrant test as well too, we can show, we're going to create our water flow supply graph so we can see, do we have enough water to design our fire sprinkler system? If that fire sprinkler system is being fed by a municipality water supply, we need to make sure that municipality water supply is up to the task to feed into our fire system. And here, that's where we're going to do that with our hydrant test to find out how much water is available for that test. And then some of our last pieces of equipment we're going to talk about today is when we do firefighter hose valve testing, internal hose valve testing. As we know, when we're inside buildings, we're inside high rises in the stairwells or in the middle of the hallways. We have hose valves there for the firefighters to hook up their hoses to go and fight the fire. Here we have our inline pedaless nozzle kit. So this uses our pedaless nozzle technology, and we basically turn this into a Venturi flow meter, a portable Venturi flow meter. So now we can hook this up to any standpipe landing valve connection, fully charge our units. We can document our static and residual pressures. If it's a PRV valve, right? If that PRV is working, we're going to be able to document that with our static residual pressure check. And then our smart monitors can be installed there to get our high and our low pressure reading. We set it all up in our mobile app, right? And now we have our flow rate designed right there in our app. And then our gate valve here is going to connect to our discharge hose, and then we can discharge that water to wherever it needs to go, whether it's up outside the building, up to the rooftop, or to an express drain if there is one in the stairwell. Well, I thank you for your time, for joining our webinar today. We're going to be out here again for a little bit longer, answering any questions you may have. But if you don't have any questions today, but you come up with something later on down the road too, feel free to reach out to me or my colleague Matt here for any questions and however we can help you guys out.
Thank you very much indeed. I really enjoyed that. As a long firefighter, that was significantly interesting, especially when you start talking about high rise. And obviously, high rise firefighting has become very prevalent over recent years, and you've seen some of the high profile incidents that have happened globally. And obviously, for those that are going inside, especially your last slide there, shows the importance of making sure that we get the flow and the pressure in order to not only extinguish the fire, but to allow us to protect our firefighters. So that test is really vital. And it takes me right back to the old days when I was riding the fire engines. We used to test the dry risers, where our method of testing was working to the top landing valve, running a line of hose out onto the roof, and making sure we got a decent flow out of the jet at the end of it. So the scientific elements that you're putting into it give me a lot more comfort than actually knowing that I've got a jet at the top end. So we did have one question that came in from Abdullah, which I will read to you. And then I'll come back to one that Nafis spoke of as well. And Abdullah asks, in a hospital fire pump test, churn test, what indicators, what readings or what indicators would cause you concern, and what should he look for to try and give an indicator the pump may not provide the water in the case of a real fire?
Yeah, absolutely. So when we first turn that fire pump on, we're going to be using a few different senses, right? Number one, we want to listen. Listen to that fire pump. Does it sound normal, right? Are we hearing any popping sounds, air being trapped in the fire pump, right? Is there that fire pump cavitating as that's spinning around, or is there even any debris that's in there? Sometimes it sounds like maybe rocks are spinning in the fire pump, but a lot of times what that is, that's air that's being trapped inside that fire pump. So we're going to be listening for any unusual sounds, any unusual vibration patterns, right? That if it, that fire pump will vibrate pretty heavily, even if it's just a little bit not aligned properly. So that's some of the first things we're going to be looking for. We're going to be checking our packing glands. Both sides of the fire pump, we have our packing glands. The packing glands is what wraps around the shaft of that pump as that shaft is spinning to make sure it cools the shaft down. We want to make sure that those packing glands are dripping 1 drop per second on each side of the fire pump. Otherwise, we're going to see that fire pump overheat pretty quickly. If we see that fire pump start to steam up, most likely that's going to be a packing gland condition that needs to be addressed. We're going to be checking for any leaks that shouldn't be there. We want to make sure our relief valve is running properly. There's quite a few we can go through, right? There's the biggest things. When it comes to measuring the fire pump itself, we want to, again, it's that suction minus discharge pressure, our net pressure that's being created by that fire pump. We want to compare that to our placard of the fire pump. Per NFPA 25, we want to be within 95% of that churn pressure. For instance, if that max net churn pressure is 100 psi, we want to make sure our suction minus discharge is at least 95 psi or better than to be closer to that churn pressure, that it's providing enough adequate pressure. All these things, we can go in. There's quite a few checklists that we can go through. A churn test itself Those churn tests, again, should be done either weekly or monthly, depending on the type of fire pump test, making sure we're exercising that motor. The biggest thing to remember is that these are motors, right? Just like our vehicles. If we only started our car one time a year, how long is that car going to work for us, right? Before we have any major maintenance issues. So with that fire pump, we want to make sure we're turning it on, exercising it on a regular basis per code, which again could be weekly if it's a diesel engine, or some electrical engines as well need a weekly churn as well too. There's certain setups that require that. So there is quite a few details, right, that we can kind of keep going into of what to be looking for on those tests. I forget to mention in one of our slides there, but we do offer Hose Monster University, which is a 2-day class on fire pump testing, everything Fireflow testing, fire hydrants, standpipes, fire pumps. It's a half classroom, half hands-on test. Currently, we offer this 4 times a year in the United States. We have people from all over the world who attend these classes. These are done at prestigious flow labs around the United States. It's a half hands-on, half classroom experience where we're going to go through the code in detail about each component and all the details of those tests. And then we're going to get hands-on with all of our equipment doing actual fire pump flow tests in a variety of fire pumps, diesel engines, electrical engines, and different types of pumps as well.
Super. I think that's a really comprehensive answer. And so, yeah, hopefully that gave you the answer you're looking for, Abdullah. Now, Shriv Jadej asks, basically, he makes the assumption that flow meters can measure flow downstream of deluge valves.
They can. I've never seen one for a deluge valve set up in that manner for a Venturi flow meter. There's probably ways we could do it, though. We would have to look more details into the design of that.
Super. And then Rathanakara asks, does the equipment require periodic calibration? And if so, what's the duration? And who provides a calibration certificate?
Yes. So all test gauges and a flow meter should be calibrated on an annual basis. All of our products are FM approved, right? But as well as outside of our FM approvals, making sure that our gauges are accurate. We want to make sure that it doesn't matter if you're using an analog gauge or a digital smart monster gauge, those gauges should be confirmed to be within calibration every year. Same thing with flow meters as well too. The gauge on the flow meter needs to be calibrated. A lot of times, because those flow meters are owned by the building owner and not the contractor who may be coming on site, where the contractor is going to bring his smart monsters or his calibrated gauges to the job site. He doesn't have a lot of control over that gauge that's owned by the building owner, but it's making sure that gauge does come out and get sent away for calibration. The whole unit, the whole flow meter doesn't need to be uninstalled. It's just the gauge itself, unhooking the hoses, taking the gauge off, and send that in for calibration. We offer gauge calibration services in the United States. We're working with some partners around the world as well too to set up calibration services for any of our devices. However, you can work with any gauge calibrator in your region that has the proper qualifications. We would call it NIST certification, the National Institute for Technologies, that allows for gauge calibration process.
Excellent. I think that's a really comprehensive answers, and it also answers Sheikh Mohammed Yassin's question about what approvals of the FM approvals. And Rafan has asked, can they get a contact email for yourselves in case they've got a future inquiry? So we'll get that put in the chat shortly. I can't see any more questions popping up. There you go. Patrick at hosemonster.com has been put in there for you to get hold of Patrick. I liked a significant statement that you made, Patrick, as you were going through the presentation. And it really struck at my core. It says, never forget the lives you saved by the work you do today. Now, really, that's tremendous, because what it says is actually we all have a responsibility to do our work properly. And the minute details that we apply or we pay attention to, and we're doing our due diligence, doing our work properly, actually make the world safer or make the environment safer for the people who come on behind us. So I really liked that. And a guy called David Campbell said to me one day along the lines of, if it's expensive, people will forget the expensiveness by the longevity of the product. So they forget how much they paid for it in the end because it's lasted so long. You've got one coming again, Abdullah. Basically, I thought we'd covered most of that, Abdullah. If we notice abnormal readings during the churn test, what should the next step be before deciding if a full flow test is required?
Well, the full flow test should be done every year, at least annually. You can flow, especially with a flow meter, right? There's nothing stopping you from flowing that fire pump more than annually, if you really want to put it under a load. But yes, you should be doing it at least annually. However, if you suspect anything is wrong with that fire pump, go ahead and and make sure you speak with your customer, right? But doing a full flow test at any time if you have any concerns about that fire pump. You don't have to wait a year to do it. Even if we just did an annual flow test last month, if you're seeing something with that fire pump that leaves you any concern at all, yeah, please take the next step in making sure that that customer is being led down the correct path for maintenance. And yeah, you do another flow test as soon as possible.
Super, thank you. I'm going to ask, are there any more questions? Because we've got about 5 minutes to run. So if you want to start putting them into your into the chat quickly, I'm going to ask Matt and Patrick just to give a summation, and then I've got a couple of points I want to draw the session to a close with. So, Patrick, have you got any other nuggets that you want to share?
Yeah, I appreciate you touch on that point of, what I said earlier too about the work that we do today matters, right? In this fire sprinkler industry, we are saving lives. We are here to make sure that not only are we saving lives, we're saving building owners, but we're saving firefighters' lives, right? If that fire sprinkler system activates properly and works properly, there's far less chance than that a firefighter is going to have a heart attack, pulling hose at 3 o'clock in the morning to go in to fight a fire. So making sure that we're able to, the work that we do today matters, and that we're going to be able to know that system is going to work properly to the best of our abilities while we're here today. Because again, we don't know when that fire is going to occur, whether it's, moments after we leave or years after we leave. The work that we're going to do today is going to make a difference in that.
100% agree with you there. Abdullah's had a follow-up question. So after corrective action, what acceptance criteria should be met during retesting before the fire pump can be considered reliable and returned to use?
It's going to be very similar, right, to that annual flow test, right? Making sure that that fire pump is working properly per that fire pump placard or the original acceptance test of that fire pump, that it's meeting at that same performance. So yes, if that fire pump is taken out of service and you perform any repairs or any modifications, you replace any major components that would affect the performance of that fire pump, we want to do a full flow test after that correction has been made to confirm that fire pump is back in acceptable order.
Super, thank you. So I'll come to Matt.
I think just to echo both your comments, really. I used to manage a team of engineers myself. I used to sleep quite well at night, but it was definitely a concern of mine regarding the quality of the engineers' work. We used to do comprehensive training. We used to use industry-leading equipment. So I think just to reinforce that point, how important it is to do things correctly, to use the best available equipment to get the best results. And I think a lot of times end users will actually pay more for maintenance if we can articulate that we're leading with innovation, we're doing it correctly and accurately. We can prove that. Sometimes trustless, if we're using digital solutions. So I think training is really important. Quality of equipment is really important, and it just raises the standards in the industry, and again saves lives a lot of times, of which we're unaware, but it's something to really be proud of.
100% agree with you. Again, at the end of the day, it is about due diligence. It's about having pride in what you do. And as Patrick was saying, sprinklers are there to control the fire, extinguish if we're lucky, but to stop the spread, to allow the firefighters to get in. So again, if the firefighters are going into an environment that is already hazardous, the work that we do in the design, the installation, the testing, the maintenance of the sprinkler systems, the dry riser, the standpipe systems is vital to ensure your firefighters come home. You know, not only the members of the public that resort to the building, but your firefighters too. So that's my emotive bit. What I always find quite amusing when manufacturers talk about the robustness of their equipment. And Patrick will smile when I say this. It has to be firefighter proof. You know, in fact, you
Right.
do a drop test. The number of times I've had, Governor, it fell apart in my hands. You know, if it can be broken, it can be broken by a firefighter, and that's very much tongue in cheek because I admire the skill, the knowledge, and professionalism of every firefighter out there globally. But again, we have
Yeah.
a reputation to be able to break anything.
Well, that's a great point too, because that's the work that we put into Smart Monster, right? We wanted to make it as easy and simple as possible for the end user to understand, right? Everyone in the not everyone, most people in the fire sprinkler industry, or like you said, firefighter proof, right? That means we have a very mechanical mindset, right? We can understand getting water from A to B, but when it comes to technology and understanding the components of an app and things like that, it can definitely be a hurdle for some of our users. So that's why we want to make it just as simple and reliable as possible. With Smart Monsters, right? You just open up your phone, it automatically connects. You don't have to pair any devices. You don't have to go through any of these steps. We've taken all the complexity and we've made it a very simple process by all of our great code workers and developers who developed this product, right, to make it what it is today, just to be very simple, easy process. So, and I should add to what I know we were talking about approvals as well too. With Smart Monsters, we are awaiting CE approval. We should have that in the next few weeks. So these are ready to ship to any CE approved land as of next month as well too. And then we'll be seeking other approvals later on down the road. So we'll be coming available in your area if you need anything other than CE approval.
Brilliant. Thank you very much indeed. So again, thank you, Patrick. Thank you, Matt. I think it was an excellent presentation. Gareth, there's been a couple of questions about getting certificates, so whether you can deal with that one for me. I'd like to thank all the attendees. I know I've taken stuff away from today, and I can see there's lots of thanks coming up in the chat box. So again, as Shriv just said, excellent presentation and thank you. So again, thank you to Hose Monster for sponsoring today's event. Thank you for Patrick and Matt for delivering an excellent presentation. Thank you for you attending. And my final thanks is to Fire Middle East for hosting the webinar, which I found most interesting. So thank you very much indeed.